Welcome to the Deep Dive. Today, we're looking at a really interesting paper called Citation Counts, leveraging cited user feedback in building a BLV-aligned dataset of diagram descriptions.
Yeah, this one tackles a pretty significant challenge, actually. How do we make visual stuff like diagrams truly accessible for people who are blind or have low vision BLV users?
Right, think about textbooks, scientific papers. Diagrams are everywhere, and they're often key to understanding.
Exactly. And just getting someone to describe it isn't always enough. This research digs into how we can create better descriptions, ones that actually meet the specific needs of BLV individuals.
Because the old ways, well, they had problems, didn't they? The paper points out that just asking sighted people to describe diagrams is, one, expensive, and two,
their descriptions often reflect what they think is important. It's a cited bias, essentially, which, might be totally different from what someone who can't see the diagram actually needs to grasp the information.
Yeah, that makes sense. It's like asking someone who sees color perfectly to describe a scene to someone who is colorblind. They might focus on hues that just aren't relevant.
That's a good analogy. So what this paper proposes is quite clever, really. Instead of having cited people write the descriptions,
they evaluate descriptions written by AI.
Precisely. They use these powerful AI models, vision language models, or VLMs, to generate initial descriptions. And importantly, these aren't just random generations, they're guided a bit first.
Okay, so the AI does the first draft, and then cited people come in as like accessibility checkers, assessing how useful that AI description would actually be.
Exactly that. It flips the role. And the goal is to be more efficient and hopefully create descriptions that are better aligned with BLV needs right from the start.
And this leads to the big contribution.
Right, the Citation dataset. It's a new, pretty large-scale collection of these diagram descriptions that have been vetted using this method. And crucially, it's been validated by professionals, educators who actually teach blind and low vision learners.
How large scale are we talking?
The paper mentions 5,000 diagrams, and get this, 137,000 samples or examples designed for different AI training tasks, like learning preferences or generating text. It's substantial.
Wow, okay, that's a lot of data. And the potential impact, particularly in education, where, like you said, diagrams are so vital, it seems huge.
It really could be. It's about pushing AI, these VLMs, to not just see images, but to describe them in a way that's genuinely helpful and inclusive for BLV users.
Okay, let's break that down a bit more. What was the exact methodology here? How do they get from diagrams to this validated data set?
So the core, as we said, is this smarter feedback loop. They didn't just throw diagrams at an AI. They used a two-pass approach to guide the AI generation.
Two passes. How did that work?
In the first pass, the VLM essentially tried to understand the diagram itself by generating questions about it and then answering its own questions, sort of like probing the image.
Ah, okay, like figuring out the key components first.
Yeah, you could think of it that way. Then in the second pass, it used those internal Q&As as like latent supervision, a subtle guide to help it write a more focused and relevant description of the diagram.
Interesting. So the AI is kind of prepping itself before writing the description.
Pretty much. Doing its homework, you might say. Then, once they had these AI-generated descriptions, multiple versions per diagram, actually they brought in cited annotators.
And these aren't the writers, they're the evaluators.
Correct. Their job wasn't to write anything new, but to assess the AI's work based on criteria relevant to BLV users. Things like factuality, is it accurate? Informativeness, does it give enough detail? Succinctness, is it concise? And even diversity, does it use varied language?
And usefulness too, right, for different tasks.
Yes, exactly. Like, how useful would this description be if a BLV user wanted to summarize the diagram or answer multiple choice questions about it, or even open-ended questions?
And all that feedback from the cited evaluators, that's what forms the citation data set.
That's the core of it. It's not just the descriptions, but all the associated ratings and preferences. This allowed them to structure citation into different parts for training AI for specific jobs, like completing descriptions, learning preferences, finding the right diagram.
And you mentioned validation by BLV educators. That seems critical.
Absolutely critical. They had BLV educators review the outputs and the data set itself, giving that expert perspective from the target user group. That adds a huge layer of credibility and relevance.
Okay, so they built the data set. Do they then prove it works? Like, does training an AI on citation actually make its descriptions better for BLV users?
Yes, that was the next step. They took existing VLMs, fine-tuned them using Citation, and then compared their output to baseline models that hadn't seen the data set.
And who did the comparing?
Crucially, BLV educators were central to the evaluation. They rated the descriptions from the fine-tuned models versus the baseline ones, and the results. Pretty significant improvements in usefulness, according to those educators. It showed the method and the data set really do help align the AI with BLV needs.
That's great validation. Now, to really appreciate this paper, maybe we should rewind a bit. What's the context here? What was the state of play before this?
Well, vision language models have exploded recently. They're getting incredibly good at connecting images and text for all sorts of tasks.
Right. Image captioning, visual question answering.
Yeah.
It's impressive stuff.
Totally. But the benefits haven't always trickled down effectively to accessibility applications, particularly for BLV individuals. There's often a gap.
A gap how?
Well, for one, the standard ways we measure how good these models are, the metrics we use often don't really capture what's important for a BLV user. They might measure general accuracy, but not, say, the specific kind of information needed to understand a complex diagram without sight.
So the benchmarks are kind of aimed at a general sighted audience.
Largely, yes. And that leads to another problem. A real scarcity of high-quality data sets specifically designed for BLV needs. Creating them is hard.
How were people trying to make them before?
Often, it relied on a small pool of cited experts writing descriptions. Which sounds good, but it has limitations.
Like the bias we mentioned earlier.
Exactly. The expert's interpretation might not match the user's need. And also, if only a few people are creating the data, you get their specific style baked in, which might not represent the diversity of needs within the BLV community. It's just not very scalable either.
You end up with a bottleneck.
Yeah.
And potentially descriptions that aren't quite right.
Precisely. Now, there was some earlier work exploring if cited non-experts could help estimate BLV preferences for certain things. But this paper really takes that idea and scales it up massively, applying it to generate a large, diverse data set covering multiple quality aspects.
And how does Citation stack up against other existing data sets? The paper mentions a few like VisText, MathVista.
Yeah, they do a comparison. Those data sets have definitely been valuable, but Citation differentiates itself. Its descriptions tend to be longer, more detailed on average.
More substance, perhaps?
Potentially, yeah. And crucially, it has that direct validation from BLV professionals across different ways the descriptions might be used. Plus, the way the cited assessment was done was more fine-grained, looking at multiple quality dimensions specifically relevant to BLV users, not just a single good or bad rating.
So it's aiming for both quantity and critically this BLV-aligned quality, validated by the right people.
That's the goal, making a resource that's genuinely built with the end user's needs in mind, even if cited people helped evaluate along the way.
Okay, the paper uses this structure, SDDSD. Let's walk through that. Starting with S for setup. What were the initial choices?
Right, setup. First, the focus diagram descriptions, because they're so vital in education for BLV learners. Then, the source material. They used the AI2D dataset.
Why that one?
Because it contains grade school level diagrams, science, processes, that kind of thing. Stuff that doesn't need highly specialized knowledge to understand. That makes it feasible for a wider range of sighted people to provide useful evaluations later on.
Makes sense. Keep it broadly understandable. And the AI generation part.
That's where they use that two-pass guided generation we talked about with models like GPT-4o MNI and QNN to VL72B. Generate Q&A first, then use that to guide the description writing. For the evaluation phase, they picked 1,000 diagrams and generated 4 different descriptions for each one.
4 different AI attempts per diagram. Okay. Next D, data collection. What do the cited evaluators actually do with those 4 descriptions?
They had 3 main tasks. First, pairwise comparison. For a given diagram, they'd see 2 of the AI descriptions side by side and had to pick which one they thought was better or more helpful for a BLV user.
A direct preference choice.
Yep. Second, rating. They rated each of the 4 descriptions individually on those 4 aspects: factuality, informativeness, succinctness, and diversity, using a 1 to 5 Likert scale.
Okay, give more detailed feedback there.
And third, sentence contribution. For each description, they had to pick the single sentence that they felt added the most value or was the most important contributor to its overall quality.
Interesting. So identifying the core nugget of information.
Kind of, yeah. And across all these tasks, they gathered a lot of annotations, over 11,000 individual judgments covering almost 1,000 diagrams and nearly 4,000 descriptions.
That's a solid amount of human input. Which brings us to the next D, dataset construction. How do they weave all that feedback into Citation?
This is where it gets structured. They didn't just dump all the descriptions and ratings together. They processed the annotations to create specific subsets tailored for different AI training goals.
Like what?
Okay, so for training models just to generate descriptions, they created citation completions. This includes the descriptions that got high ratings, maybe instructions related to those ratings, like generate an informative description for this diagram.
Guiding the AI towards specific qualities.
Exactly. Then for learning preferences, there's citation preference. This uses those pairwise choices. This description was chosen, this one was rejected. They also used the rating scores to infer preferences and even generated some deliberately worse descriptions to act as negative examples.
Creating synthetic bad examples to help the AI learn what not to do. Clever.
And for retrieval, finding the right diagram for description, they created citation retrieval. This pairs a diagram image with its best descriptions, based on the feedback, and also includes hard negatives.
Hard negatives.
Yeah, descriptions of other diagrams that look visually similar, things that would likely confuse a basic AI model. This forces the model to learn finer distinctions. They also briefly mention creating versions for VQA and reasoning, using the high-quality descriptions to generate related questions and reasoning steps.
Right, so a suite of task-specific data sets built from that core evaluation data. Okay, next, experiments and evaluation. How did they test if citation actually improves AI performance?
They ran fine-tuning experiments. They took models like Qwen2VL, both a smaller 2 billion parameter version and a larger 7 billion one, and also BLP2, and trained them on the relevant citation subsets.
So training for completion, preference, retrieval.
Exactly. Then came the evaluation, which was pretty multifaceted. They had BLV educators assess the outputs, focusing on text qualities like succinctness, diversity, and usefulness for specific tasks. Summarization, MCQs, open-ended questions. They called one quality interpretativeness, too.
Interpretativeness, what does that mean here?
Essentially how easy it was to understand the description and build a mental model of the diagram from it. They also got feedback from cited educators on things like factuality and informativeness.
Okay, human evaluation from both BLV and cited perspectives. Anything else?
Yeah, they also used an AI judge, a powerful model called QVQ72B Preview, to rate the outputs automatically, and they included classic automatic metrics like BLEU or Rouge, though, as we'll see, those weren't always the most informative.
Right, so a mix of human expert, human non-expert, AI judge, and standard scores. And the final D results. What did they find? What was the bottom line?
The feedback from the BLV educators was key. They measured the effect size, how much difference the fine-tuning made. And training on citation, especially the smaller 2B model, showed significant positive effects on many qualities the educators cared about. Interpretativeness, diversity, usefulness for open-ended questions.
So the data set genuinely helped the AI produce descriptions that BLV educators found better.
Yes. And interestingly, that initial guided generation process we talked about, its benefit was most pronounced after the models were fine-tuned on citation.
Meaning?
It suggests that citation teaches the model what kind of information is valuable for BLV users, and then the guided generation helps it deliver that information more effectively. The two work together synergistically.
That's a really important finding. Did the size of the model matter much, 2B versus 7B?
There were some nuances. The combination of fine-tuning and guided generation affected things like succinctness and interpretativeness differently for the 2B and 7B models. It suggests, that model size and architecture still play a role in how well these techniques work. No single silver bullet.
And what about those standard automatic metrics?
Well, they often like the guided generation output more, but those scores didn't always correlate well with what the BLV educators preferred, which really underlines the point. For accessibility, you can't just rely on standard metrics. You need human feedback, specifically from the target user group.
That echoes what we often hear in accessibility research. The standard benchmarks just don't capture the nuances. So stepping back, what are the big picture real-world implications here?
I think they're potentially quite significant. Citation and the method behind it offers a more scalable and potentially more effective way to create accessible educational materials. Diagrams are just one example. This could apply to other complex visual content too.
And it's more cost-effective than relying purely on human experts for every single description.
That's the idea. Using AI for the heavy lifting of generation and cited evaluators for targeted feedback seems more efficient. Beyond education, this could spur the development of VLMs that are just fundamentally better at describing the visual world for BLV users across many applications. Web browsing, interacting with devices, navigating environments.
And that validation by BLV professionals is key for building trust, right?
Yeah.
Ensuring these tools are actually useful and not just technically clever.
Absolutely. It's about co-designing or at least co-validating with the community that stands to benefit. That's crucial for adoption and real impact.
It definitely feels like a solid step towards more inclusive AI. Okay, that brings us to our novel notions segment. Where could this research lead? What are some potential next steps or interesting tangents?
Well, this work opens up some cool avenues. One idea is to explore more personalized cited feedback. Right now, the cited evaluators give general feedback. But what if you use feedback from cited people who have a close relationship with a specific BLV user?
Like a family member, or maybe a teacher who works closely with BLV students.
Exactly. These individuals might have a much deeper, more nuanced understanding of the specific information needs or preferences of the person or people they support. The paper itself notes that reader-specific needs are important.
So how might that work, like a special interface for teachers?
You could imagine, yeah. Maybe a tool where a teacher of visually impaired students could review AI descriptions for materials they plan to use, highlight sentences that are particularly good or confusing for their students, and that feedback loop could fine-tune models specifically for that classroom or even individual needs over time.
That taps into both the visual grounding of the cited person and their practical understanding of the BLV user's context.
Right. And it might reveal, subtle linguistic patterns or types of descriptions that work best for different learning styles or levels of vision loss within the BLV community. It could get really granular.
That's a really compelling direction. What's another potential research idea stemming from this?
Another angle could be integrating multimodal feedback during the refinement process. Currently, the feedback is text-based ratings, preferences, sentence choices.
Okay.
But what if cited evaluators could provide feedback more directly related to the image itself? For instance, using gestures on a touchscreen to highlight regions of the diagram that are well described, or maybe parts of the description completely missed.
So linking the text feedback directly to the visual elements.
Exactly, or even perhaps using something like eye tracking. See where cited evaluators look on the diagram as they read the description. Does their gaze match the focus of the text? This could give a much richer signal about visual grounding and relevance than just text ratings alone.
That sounds technically complex, but potentially very powerful.
It could be. The paper mentions limitations of current methods relying heavily on Q&A formats and the potential for segmentation. This multimodal feedback could provide that richer signal, maybe revealing non-obvious links between specific visual features and what makes a description truly useful for someone navigating it without sight.
Two fascinating possibilities there. Personalization through connected cited individuals, and richer feedback through multimodality. Of course, as always in this segment, these are just speculative ideas for discussion.
Absolutely. Just exploring where this kind of innovative work might lead us next.
So, wrapping up our deep dive today, it's really clear that this paper on citation and leveraging cited feedback is a significant contribution.
It offers a practical, validated approach to improving diagram descriptions and potentially other visual descriptions for blind and low vision users.
It tackles the bias and scalability issues of previous methods in a really smart way, using AI generation guided by human assessment that's focused on BLV needs.
And the resulting citation dataset seems like a valuable resource for the research community to build upon, hopefully leading to more capable and truly accessible AI systems.
We definitely encourage you, the listener, to check out the paper if this topic interests you. We'll have a link in the description.
Real worth the read.
And that leaves us with our final thought for you to ponder. How will data sets and methodologies like this one, focused on specific user needs and validated by those communities, truly reshape the landscape of AI accessibility? And maybe even lead to more personalized AI experiences for everyone.
Something to think about. Thanks for joining us for this deep dive into machine learning for accessibility. Until next time.